Hello, everyone. And well, if you see me laughing, it's because I actually have people talking in my ears. Good afternoon. It's a very hot afternoon, and I'm locked in my home office. But what better way to cool down than actually talk about security and talk about Vault? So let's assume for a second that you are in a stage where either you have one application that is currently being secured by Vault, and you are potentially looking at supporting other applications. Or you are in a position where you have to support multiple teams in operating Vault. Long story short, if you are anywhere in this line, well, you might get some value from this talk. My name is Nico, and I would urge you to call me that. As you can see, I'm a couple of kilos lighter than the actual picture, which was HashiCorp last October, I think. So I'm the regional director for solutions engineering, which means, in less words, that I manage a team of about 25 brilliant individuals, including Dom. I feel sort of blessed by the chance of actually being able to have contributed to the product. So if you're using like the console or the Nomad secret engines, you're very welcome. If I actually broke your workflow sourcing entropy, I'm not really sorry, because you shouldn't be getting that much entropy at once. During my career in HashiCorp, I have helped a number of organizations in operationalizing Vault and actually running these platforms at scale. Been in HashiCorp for about 3.5 years. So we tend to do the joke about dog years, and yeah, it's a lot of years in HashiCorp. I've been using these tools for a long while. I absolutely love interacting with them. So you can find me in the usual places. But most importantly, what are we going to be talking about today? We are going to hopefully, or I have hopefully collected most of the best practice that we have available in regards to how to operationalize really large scale Vault deployments. Most importantly, and as I put in the slide, this is the no wireboarding approach. Okay, this is not the custom integration. This is not how to pull the other tool from this thing. This is how Vault works and was designed to work. And as such, as you can imagine, this is fully supported. If you are a customer, you can go and reach support. If you're not a customer, you can go and reach in forums and people will know what you're talking about. Okay, it's an approach that tries to not introduce friction, although we're going to talk about where potentially the friction points are when using Vault at scale. It's talking about using Vault as a capability, not as a tool. So if you're using Vault, let's say, as part of your pipeline to get, an SSH sign key for a system, and you're using it just as a tool, this is not the kind of patterns that, some of them will be helpful, but this is not the kind of patterns that potentially you're going to be looking into, okay? It's going to be pragmatic in every sense of the way, where effectively you can do things with open source. We're going to tell you, this is the kind of things you do with open source. When you're going to do a commercial feature, I am going to talk about commercial features. And ultimately, everything that I put in this presentation is both documented somewhere in either our resource page, or our documentation, or our Learn guides. And it's ultimately HashiCorp sanctioned. So let's start kind of on that day zero. And I always like to do a very, very quick introduction, because we have a fairly mixed audience. I don't know how many people. But some of you may have been using Vault for a while, and some of you may have no idea what Vault is. And also, there is one thing I always like to agree and sort of make a contract with you. What is actually the definition of the secret? And by the way, this is from the Cambridge Dictionary, so as some people may call it, this is the Queen's language. And ultimately, a secret is a piece of information that is only known by one person, or very, very few people, and should not be known by others. And based on that secret definition is kind of how we designed Vault. The first aspect was, before I kind of give you a secret, I need to know who you are, okay? And traditionally, we had other people sort of do that introduction of a system in an environment of compute trust. We wanted to take that out. So as you can imagine, the first thing we looked at is who is the primary audience. And I think Chris and Aaron just said a great metaphor. Right? What is the primary audience for Vault? Well, it's an application. So the interface must be programmatical. It's also the minimum common denominator between access, when it comes to access. Because on top of that API, we can build a web UI, we can build a CLI, but ultimately applications can only talk through that API. There is another interesting concept, which is, some security products or some products overall have sort of bolted on an API on an existing product when like, okay, now it's programmatical access. But the workflows haven't really felt right for programmatical access. That is not something we did in Vault, because if you have the chance to look at the source code, you will see that there's actually no way of exposing things in Vault outside that API, either the HTTP REST API or the KMIP API. The second aspect we need to handle is, as I mentioned, before I give you a secret, I need to know who you are. So if you're a human, we know how to assert humans' identity in a compute trust environment. They're going to have an AD account, they're going to use some sort of federation system like Okta or Ping Identity or Auth0, they're going to use multi-factor. That's fine. We know how to handle that. But if you're a machine, that has been a challenge for a lot of organizations. So we went back to looking into what do we actually trust. And if you're in AWS or GCP, you trust a system called IAM. They do different things, but they are named in the same way. But ultimately, Azure has its alternative in Azure application groups, and Pivotal has its alternative, and Kubernetes has its alternative in namespaces and service accounts. But ultimately, we wanted to get to a point where an application that has just been deployed, or a system, it could be an EC2 instance, could be an Azure virtual machine, could be a pod, they can just go from zero trust to identifying themselves with Vault and ultimately getting into that trust environment. No human interaction required. If you're doing this kind of authentication in Vault, you are using it right. If you're not, you probably should be looking into a couple of things. Once I know who you are and I establish my identity, for those that have been using Vault, you know that where you logged in as a user by ID or you are an EC2 instance, you're going to get a short-lived token. That short-lived token is going to basically have a number of policies associated that not only dictate what you can do, i.e. consume the secret or store the secret, but also, and this is more on the commercial side, they look into under what conditions you can do it, right? Like, for example, you're a user, you can get this secret if 3 other people from this LDAP group actually allowed you to get this secret. Or if you're trying to get this secret on a change window. As you can imagine, this is a system called Vault. Everything that comes out of a Vault needs a very, very long paper trail. We do have an audit subsystem in Vault. It will send information to whatever your auditing system is or your SIEM system is. There is one thing I do want to kind of make very clear. There are certain endpoints in Vault that through your audit system, you should be alerting on access, if you will. Most of this access will probably be legitimate, but for example, and we're going to talk about this more in detail, if someone initiates a key rotation, you actually want to have all alarm bells ring. Ultimately, it's a protocol Vault, it stores secrets. That probably comes at no surprise to any of you. Okay, it can store static secrets in the same way you can go and put a piece of paper with a secret written in a physical Vault. But we want to take the human out of that go and identify yourself. We also want to take the human out of go and generate the secret. So surely you can get a secret as you have right now and put it in Vault and have Vault go and rotate that service principal or that user account with databases, right? This is very common. But also Vault can go and reach out to third-party systems and generate access based on sort of least privilege and a set of accounts. And as we can make these secrets very, very easy to access, we can also make them very, very short-lived. Okay. We do this across multiple platforms, across SSH and Active Directory and databases and cloud partners. I'm not going to go into a lot of detail on that. Then we also provide a set of cryptographic capabilities where Vault kind of holds your cryptographic material and just exposes like an encrypt or a decrypt endpoint, okay? Or does format preserving encryption, as Andy was talking about just this morning, I think. Or holds cryptographic materials for other systems that generally through KMIP go and do transparent data encryption. So now that we have kind of this good idea of the functionality of Vault, key point that I want you to take from this is Vault is a broker for access, right? If I go and present an identity to Vault, based on my identity, Vault is going to give me access to a system, okay? And it can do it for humans or it can do it programmatically for systems. Most of our users and customers actually use Vault mostly for programmatical access and so on. Now, in order to keep these secrets, as you can imagine, there is a whole lot of encryption going on. whatever secret we store or whatever information we store is actually protected by a storage key, okay? Everything that leaves Vault, and when I'm talking about leaves Vault, if you're using the console backend, it is actually encrypted by Vault before it goes into the console backend or the integrated storage backend or whatever other backend you may be using. We have a storage key that actually protects that information, okay? But of course, we cannot store that storage key in plain text, so we need to wrap it with something. Well, we wrap it with a master key, okay? That master key, if you have been using Vault for a while, is protected by virtue of sharding it and using an algorithm called Shamir secret sharing. But most recently, and when I say recently, I actually say a couple of years, we had a lot of operational issues in both customers and users around the management of those keys. So we started introducing this concept of a seal key, a third-party cryptography system that can actually protect that master key. Now, guess what? All of these keys actually need to be rotated on a cadence, and they require, different actors to be involved. For example, the storage key that just, protects secrets at rest, it may just need an operator, but some more keys are going to need more than that. The way you traditionally deploy Vault, and this is kind of the best practice, is, well, guess what? Vault is actually a system designed in hindsight of cloud adoption. So it's actually designed to run in a way where it doesn't expect any resiliency to be available from your infrastructure. So for example, you could be running 5 nodes of Vault using the integrated storage backend, and the only thing you need is a load balancer and your external seal. Or you could be running 3 nodes of Vault, backed by a console cluster of 5 nodes that is doing the storage. Everything you're going to need here, as I mentioned before, compute, a load balancer, and your seal key, okay? If one node goes down, another takes its place. I'm going to talk about all these resiliency patterns in a second. Ultimately, this is how you scale sort of your single site, but at global scale, you can actually have replicating Vault clusters where effectively, certain data is actually replicated in an active, it looks like an active manner. Vault is actually doing the heavy lifting to, another geo. We're going to talk about that in a second, probably more when we talk about the resiliency patterns. So how does Vault look like in your day one? What things that you need to take into consideration? So the first one, when deploying Vault, we seriously prefer that you would deploy Vault immutably. Why? Because if you have, first auditability, right? Every time that Vault is deployed, is back to that original footprint, maybe using Packer, that you used to deploy it. You can also, when you do changes, you can be sort of forced to do changes that go through your whole pipeline and execute all your security tests and so on. We're trying to avoid people SSHing into the system and trying to poke memory in the system, because Vault actually keeps some sensitive stuff in memory that you need to be aware. Now, of course, a number of organizations are just not ready for this. And this is where configuration management really, really helps. Okay, if you have a good pattern or a good set of practices in regards to how to manage your systems, that really helps when it comes to keeping Vault, actually in a manner that is compliant, and also avoiding runtime changes in the sense that no one is going to SSH into the system and potentially poke things out. SE-Linux in this case, or AppArmor, is not just for disabling. We strongly suggest you do it, because if someone actually gains access to that box, you want to have that kind of extra mandatory enforcement layer on top of it. Be very aware that Vault is released quarterly, at least major releases, with minors, potentially any given month. So these procedures for install and upgrade must be really, really ironed out. Okay, be aware there are a considerable amount of people that actually, have this problem, and when they realize they are 2-3 versions behind. So be very aware of this. Console can help with load balancing in case you don't want to use like a physical load balancer or an ALB or whatever. We have guides around that. If you're running Vault as central capacity, as I mentioned, telemetry is one thing you want to look into to give you insights in terms of how your service is operating. And auditability is important. I mentioned some of the endpoints there, but sys policies, sysRIKI, those are the endpoints that you really want to have alarm bells going on if someone tries to access them, because they are potentially changing the data structure or your security profile in Vault. Vault is like a very, very runtimey thing, so that the object is always try to keep it running, because just imagine for a second you're using static secrets, right? And you have all these credentials for these instances of an application that, I don't know, expire in 10 minutes, right? In 20 minutes, your Vault crashes, for example, and you go and do a restore with information from an hour ago. What do you think Vault is trying to do? It's going to just try to do revoke operations on secrets that it has already done. So backup and restore, yes, absolutely, do it. It's probably part of your organizational best practices. From an operational perspective, you will hear that we sometimes talk about a DR cluster, if you will. Traditionally, what you would do is you would fail over to DR. It's much easier, and you'll have already another warm cluster ready to go. Now, that warm cluster is going to come really into consideration when it comes to certain recovery scenarios, because, as I mentioned, Vault is designed to run in a way where it doesn't need any resiliency from the platform. No shared storage, just a load balancer to kind of give away the traffic. So if an individual node fails, guess what's going to happen? If you go and stop Vault on a node, another cluster member will just take its place. No extra configuration required. If a node actually fails, that failover may take about 45 seconds, or rather exactly 45 seconds, because it's guided by some timeouts. But the recovery is happening automatically. You don't need any operational overhead with that. If your whole cluster fails, and of course you're using a sort of secondary storage backend, you can just provision our cluster. Or you can just restore your backup. Okay, it is a resiliency strategy. If you're using console and a console node fails, pretty much the same as Vault, nothing will really happen. Even if you lose the console has this concept of a leader node. Even if you lose that leader, things will keep operating just fine. Okay, and our leader will be assigned. Now, if you actually lose quorum when running console, for those that don't know console, there is a reason why I was using odd numbers. And it's because you always need to maintain a consensus, a quorum of systems for the system to actually operate, okay? If you lose that quorum, you may be tempted by the side by the console side to actually attempt to do a recovery. Truth is, from an RTO, RPO perspective, to get your Vault up and running, it might be much, much faster to do a backup. So just take that into consideration. Now, if you're using an external seal, which most of you should be using, be very aware that if a seal key is compromised or it fails or is held ransom, it is literally game over, because this is part of the promises we do to users when they are using Vault. If I sort of enable you to recover from that seal key failure, that means that my cryptographic structure is not as strong as it should be. The reason this is running in banks and health and heavy regulated industries is because of this. And these are kind of the trade-off where you look at Vault and you say like, wow, this is absolutely a thing. From an operational perspective, this is really, really smooth. And people forget this is a security product. So sometimes there are certain things where we need to introduce friction, and the seal key failure is one of them. One of the recovery the recovery scenario for this would be traditionally to fail over to a DR cluster that has a different seal key. If you're using open source, you would have to find a way to encrypt that key, either pulling it through a system through envelope encryption or something like that, in order to be able to recover from that. But this is one scenario that you need to be really, really aware when it comes to recovery. Now, those keys I was talking about, the storage key, the master key, the seal key, those traditionally don't exist in day zero. They are provisioned by Vault. And these actually should be carried out in a ceremony. And we always talk about just that Vault init command, and you may have read the documentation. And it might be slightly misleading because it goes through the steps, but it doesn't really go through the ceremony. Which, by the way, that ceremony, if you don't carry it like this, it may actually end up looking like this ceremony if ever your keys get compromised. But ultimately, just to go real quick through this ceremony, when you start, you have this Vault cluster that is installed, running, but uninitialized. You're going to have a couple of personas involved here. You're going to have a number of key holders, by default is 5, which are designated sort of operators. And remember, these key holders are going to sort of guarantee that cryptographic trust of Vault. Okay, why? Because literally a quorum or a consensus of them actually holds the keys to the kingdom. Okay. These key holders are going to have for this ceremony a set of GPG keys. You're also going to have an operator that is also going to have a GPG key. Now, the way you actually should start this initialization process is by the key holders giving public GPG keys, like using sort of envelope encryption, to the operator, and the operator actually sending these, public GPG keys and its own to Vault. Vault will actually start then the initialization process and return to that operator, a set of GPG encrypted recovery keys or unsealed keys if you're using Shamir, okay, which are going to be passed back to the key holders, and only each key holder can decrypt it. And it's also going to get a GPG encrypted root token. Now, this is very important because no matter how many times I say it, I keep finding it. This root token should only use for a little subset of things. It should be used to set basic authentication, basic policy, and basic audit into Vault. Once that is set up, that operator needs to revoke that key, because from there on, it can log in using LDAP or GitHub or whatever and use the actual policy system. That is the only time where the key holders can actually leave the room, when they are sure that there is nothing that is overriding the policy system. So I talked about a number of operational roles here in Vault, but let's talk a little bit about in the organization. There is generally a team that runs a Vault capability, kind of an operations team, and that is generally, people running services in, like, if you have an AWS landing zone in your shared services account, or SREs, or people running things like your version control system or your CI, part of development tooling. Okay, these are generally the profile of the individuals that run Vault, although some security teams actually run it for others. There are consumers in the organization, which is ultimately everyone that needs a secret with different levels of skill. There is kind of InfoSec and cryptography people that generally handle that key rotation, for example. They review the architecture and they give guidance. And there is always an audit team. That is the one that is ex post facto looking at the audit logs from Vault, and potentially these are the ones that are going to come back to you if you initialize a rekey and ask why is it being done, or probably why this is being done out of cadence. So a couple of things. Vault has actually a pluggable interface. So in terms of the authentication or secrets, you can just build your own to integrate your own system or a third-party system that we have not taken into consideration. A couple of things to take into consideration. Every member of the cluster must have the same binaries for plugins. Those trees for development live actually outside Vault, so you can develop it on its own. They communicate through like a gRPC interface. So basically these are standalone. If a plugin crashes, it doesn't affect your existing Vault. This is a very, very lean layer of software. And if you want to write one, I'm sorry, but I can't do it for you. But you can check my talk from last year, which actually talks about how to write secret engines. So let's talk a little bit about kind of your day two. Let's assume for a second you have followed all these practices and Vault is set up. The way you consume secrets, as I mentioned in the beginning, you authenticate using an identity that you trust. Okay, it could be a GitHub token because you use that for deployments. It could be UpRoll. It could be AWS. But ultimately, you let that workflow authenticate and establish your identity before they consume secrets. Okay? And then in the way on how to consume it, there are actually a number of ways. You can just talk to the Vault API and just retrieve a secret on runtime in the application. Or you can, without touching your application, actually have, a Vault agent that templates that information. You can pass it through environment variables. Or you can use some sort of configuration management or like a third-party pass-through. If you just can't change this application and you need to get a secret to it, you actually have a system requested for Vault and pass it. But if you do that, it needs to be wrapped using response wrapping. In that way, when it gets to the workload, that workload will try to unwrap it, and that unwrapping can only happen once. So if the workload can unwrap this secret, you know that that secret was intercepted. If you're using Kubernetes, one of the most popular methods I've seen in the past 2 months or so is actually using our kind of agent injector as a sidecar. It literally uses, a kind of a mutation webhook in Kubernetes to, create a file and mount it to other containers in the pod. And as I said, mutant, as you can imagine, I have a mutant that is actually very impressed with that. But yeah, this has been super impressive. I work with a couple of organizations that actually have, loved it. Now, in terms of how to operate this at scale, what traditionally happens when you have like one Vault running is you have a central team kind of with a ticket queue that is literally just getting requests of 4 people. Like, I need to mount this, I need to authenticate with that. I have my Kubernetes cluster that cannot authenticate. I need this custom policy, which is, when it comes to system of coordination, is both slowing down developers and driving that central team crazy. This is kind of where we really build commercial features to try to help with that. And potentially, and by the way, you may see in the slide that there is a little mistake where one endpoint is actually repeated. But anyway, the way you should be running this is actually through a namespace capability, where you have a team that handles certain operational aspects, the install upgrade, the key rotation, the backup and restore, and so on. And from there on, you can simply shift those capabilities to the left. Now, how to keep it running, and I'm going to try to wrap up because I'm, as usual, late. You need to rotate all those keys on, maybe a separate cadence, but the storage key is easy. You just Vault operator rotate. It can be done by a privileged individual, and you probably maybe want to do this every quarter or so. That master key rotation procedure is similar to the initialization, but where the operator will actually start by sending the new GPG public keys. It could be the same, it could be new, okay? And then that operator will receive a parameter from Vault that will be passed so the key holders can authenticate that this is a valid operation. Those key holders will send their shard and the nonce to Vault in a way where ultimately a new set of shards will be passed to the key holders. They're generally retrieved by an operator with a backup token. If you're promoting a DR, you need to run a similar procedure where you create a DR operation token. And as usual, that operator is going to send a GPG key in order to have that DR operation token encrypted, and the key holders are going to run a similar procedure where they send that GPG key, they're going to get a nonce, and as you can imagine, they are once again going to send their shares of the key in order to get that DR operation token that is once again GPG encrypted. Remember, updating Vault, immutable is always preferred. Okay, try to keep it running and try to redeploy it always from the start. It helps with patching, it helps with everything. I don't think I need to preach to the choir here when it comes to doing immutable infrastructure. We generally recommend doing a blue-green deployment pattern, like, provision a new Vault, destroy your old one once everything's settled. Remember that the new major releases are done quarterly. Check the changelog. We have update guides in the documentation site. Look into it. Remember that minors update monthly, and that plugin updates are actually handled independently. And as I said before, in every member of your cluster or your clusters, you need to have the same version of a plugin. So wrapping it up, a couple of points. Vault is, as you can see, a really, really safe product. We put a lot of care and consideration in regards to how we design this, and we try to strike the perfect balance. No one is perfect in regards to kind of practicality and security. And as such, remember, Vault is a security product. So there are going to be things that are going to seem like they introduce friction. They are most likely not designed to be automated. So if you're in doubt, please reach out to us and we're happy to educate you on that. Okay? Some of these procedures I showed you, make them part of your runbook. If you're running Vault, really start looking into how do I rotate keys? Have I initialized Vault correctly? And so on. Now, Vault on its own is fantastic, but it's not magic. It's people and process that actually make Vault secure. And in this, you do not want to compromise, because Vault potentially now is actually holding the keys to your castle. And when it comes to security, where you're paying for the software or not, believe me, we are going to want to help you on this. So ask for help if you have doubts. And ultimately, this presentation is current as of the 24th of June. So please read the docs and ensure that what you're doing is actually current. With that, I would like to thank you all. I would like to thank my colleague Louis for taking the Q&A, and I'm signing off for today. Have a good day, and I hope you really enjoyed HashiConf. So over to the MC.
So actually, I'm not sure if I hear you, Rob, but you're going to stay here for a little bit longer.
I'm going to stay here for longer, but I make Paul and Robbie miserable already every day. Like they hate me if I make them late.
Wave and smile. Selfie.